Right now, I want to talk about definition, scale, and vector. Okay, we use two kinds of quantity in machine: scale and vector. Scale quantity are those with which only a magnitude is isolated. Example of scale quantity are time, volume, density, speed, energy, and mass. Vector quantity, on the other hand, possess direction as well as magnitude and must obey the polygram law of addition as described later in this article. Example of vector quantities are displacement, velocity, acceleration, force, moment, and momentum. Speed is a scale. It is the magnitude of velocity, which is a vector. Thus, velocity is specified by direction as well as a speed. Vector representing physical quantity can be classified as free, sliding, or fixed. Okay, the first one, a free vector, is one whose action is not confined to or associated with a unit line in space. For example, if a body moves without rotation, then the movement or displacement of any point in the body may be taken as a vector. This vector describes equally well the direction and magnitude of the displacement of every point in the body. Thus, we may represent the displacement of such a body by a free vector. The second, a sliding vector, has a unit line of action in space but not a unit point of application. For example, when an internal force acts on a rigid body, the force can be applied at any point along its line of action without changing its effect on the body as a whole, and thus it is a sliding vector. And the last one, a fixed vector, is one of which a unique point of application is specified. The action of a force on a deformable or non-rigid body must be specified by a fixed vector at the point of application of the force. In this sentence, the force and deformation which is the body depend on the point of application of the force as well as on its magnitude and line of action. That's all for me for definition, scale, and vector. Thank you.
Hi, my name is Muhammad Alfiman Azizah. My matrix number is 01AKM21F1049. Today I want to tell about scalar vector in real life application in sport like basketball and baseball. Vector is used unconsciously by the player. Ultimately, they shot the target or throw the ball at a direction which an angle is done by the knowledge of vector. Thank you.
So first of all, we break the question. We have x equal 10, which is the distance from the player and the basket, and then we have y, which is 3, the height of the basket, y1, which is 2, the height of the player, and the angle 30. So we can start by finding time in the air, but we need the horizontal component, which is this thing. So to find this thing, we can use this formula: Vx, V initial cos 30, and then we will get 0.866 Vi. For Vy, we're gonna get 0.5 Vi, and then we can put it here. This is the formula: x equal x initial plus Vxt plus half at square. Since the player has no movement, so x initial is 0 and there's no force involved, so the acceleration is 0, which leaves us with x equal vxt, and then we just replace it. T equal 10 over 0.88 vi, and then we do the same thing in the y formula. We exchange it. The initial y is 3, the height of basket, the height of basket 3, and then the height of the player y1 2, 0.5 vi, and then we replace the t with the answer we replace the t here with the answer we get over here, and then we do it this. And once we get here, since the vi square over here, which right here, so it's gonna be here, and then they're gonna be a square root, and the final answer is 5.36. That's the initial velocity of the ball.
Hi guys, my name is Muhammad Samir Shafiq Muhammad Zakwan. My matrix number is 01 DKM21F1063. The conclusion of the project, we get that a scalar is a physical quantity with magnitude only. A vector is physical quantity with magnitude and direction. Vector may be represented as arrow, where the length of the arrow indicates the magnitude and the arrowhead indicates the direction of the vector. From this project, we know that a scalar and vector can be applied in basketball. They can be so widely used in real life application and not only in our test and exam. That's all from me and our group member. Thanks for watching. See you.